urban settings can produce large amounts of waste. These can leach into the surrounding soil, presenting unique challenges, so urban farmers often test their soils for contaminants like heavy metals before they get started. NRCS can provide farmers with technical information on soil mitigation strategies tailored to a farm's specific needs to ensure food is grown in a safe environment.
Let's say if you live in the city, use raised beds unless you absolutely know the components of the soil.
Okay. So being able to control the humidity, the temperature, the air quality, the water hitting the root zone directly and giving the plants all the nutrients that they actually need speeds up that process a bit. That 5-week time frame is also...
I grow a diverse landscape of flowers, diverse crops, so that I'm encouraging beneficial insects to be in my farm and they can take care of the bad insects.
All of a sudden, everything wants to eat my heirloom apples. I never had this problem before. If this keeps up, I won't have much to sell at market. I really need to consider risk mitigation strategies such as crop insurance, revenue protection plans, and integrated pest management to protect my new business.
We recommend viewers to first think about pests you want to exclude and length of protection needed. Insect exclusion practices have two basic features, design and material, that have to be in balance for best results. Design of a pest exclusion system should be sturdy and material should be low cost for wide-scale use. Also think about possible side effects of using a screen. For example, using 40 or 50 mesh insect net can exclude small insect pests, but it will also exclude beneficial insects and pollinators. Weed control is another limitation due to raised temperatures in the net house. Following slides will provide results from various design and material studies completed in Alabama. Net house is a popular pest exclusion system for vegetable farmers in many developing countries. However, it is still a novel concept for many producers in the U.S. Alabama Extension has been evaluating insect pest exclusion systems since 2010. In one of the first large-scale studies, pest reduction was highly significant for moss, stink bugs, leaf-footed bugs, thrips, and whiteflies when a 50-mesh white screen was used. That was an expensive project which sparked interest in designing low-cost systems for pest exclusion in gardens and small farms. This low-cost net house used all locally available materials and allowed one person to stand inside. It took about 2 hours to build an 80-square-foot structure after installing the drip irrigation system and planting tomatoes. We used Dalen garden net, folded twice over to make the pore size ½ inch by ½ inch. It is important to properly anchor plastic or wooden poles to the ground using camping hooks. The nylon cords connecting the poles helped distribute wind pressure and also supported the fabric above the canopy. We planted detriment tomato varieties inside this net house and had good yields. The Dalen net house was moderately effective in reducing moth numbers, quantified using sticky pheromone traps. Year 2010 was an outbreak year for armyworms, but we observed reduction in moth numbers with the net. Leaf-footed bugs could not pass through the ½ inch opening, but brown stink bugs could. Weekly treatment of pyrethrin, purchased from retail store, was used to reduce stink bug feeding, but it was difficult to apply insecticides uniformly inside plant canopy. It is important to control weeds around the structure to prevent buildup of pests. Interestingly, pollinators and beneficial insects were seen landing on the net and then crawl into the structure and vice versa. To give viewers a better proof of concept, here is a short description of a study done on 2 farms in East Alabama where squash bugs were in outbreak status in 2011. We tried the simplistic Dalen garden net along with 1-foot-high wall of white row cover at the bottom of the structure as pointed out by the red arrow. Squash bugs like to crawl on the ground and hide under leaves, so a wall was included. About 10 plants were included in the net house, and all squash bugs were removed in order to measure the reinfestation level. 10 adjacent plants were maintained as control. The study showed that squash bugs were able to reinfest the squash inside the net house, but the invasion was delayed by about 2 weeks. Plants in the net house produced fruits for 2 extra weeks, whereas the crop outside succumbed to the pest. The reinfestation levels at 4 weeks was still half the level compared to the unprotected crop. Both test locations gave similar results. Reduction in adult squash bug numbers also mean reduced number of eggs per plant over 3 weeks. Early season insect protection is often critical in the southeast where plant establishment is a problem. Here is another low-frame net house that was used to evaluate super light insect barrier, commonly available on many gardening websites, for early season pest management in tomatoes. This fabric is available in 8-foot by 20 by 48 or 96-foot pieces from the manufacturer and is very convenient to handle. It allows 90% light penetration. This fabric can be used in a variety of ways, including U-frames or low tunnels. This graph shows the effectiveness of the super light insect barrier compared to many commercial and garden insecticides. The fabric was able to reduce about 60% early season flea, beetle, and aphid infestations without the need of any insecticide. This level of insect protection was similar to more expensive insecticidal material we tested. This positive effect was observed for over a 3-week period, and the fabric was removed thereafter once the tomatoes were well established. Due to warm microclimate inside the fabric, it is important to keep weeds under check. Here are some variations to a low-cost net house. This project is being carried out in collaboration with the Bay Area Food Bank of Mobile, Alabama. Both these designs are very suitable for community gardens that have raised bed production system. A fact sheet containing details of the construction process is available on the IPM website. Here's a video that shows quick insect net installation system for raised beds using 1/2-inch PVC pipes. Participant can be seen laying down pieces of super light fabric on both sides of the bed and tucking it under the PVC frame. This can be done with steel mesh also. The pieces of fabric were joined together at the top with minimum overlap to avoid shading. The entire structure is bolted to the wooden baseboards. Fabric at the end walls was weighed down to close the unit. It is best to lay out the drip irrigation and transplanting done before putting the fabric on. With the extra heat trapped inside, weed control is a constant battle. According to our observations, a single layer of fabric does not cut out too much sunlight or trap too much heat. Once the fabric is taken off, tomatoes will rapidly grow and fruit. For producing insect-pollinated crops, producers can release bumblebees inside long net houses or simply roll up the sides during daytime for foraging bees. Closing the net house at night can reduce majority of the night-flying moths from reaching the crop. Net houses open up many avenues for integrating other sustainable agriculture practices. If you are using shade cloth as a net in a low tunnel or high tunnel, then it may be possible to release commercially available predatory insects like lady beetles and lacewings inside the net to reduce caterpillars, aphids, thrips, and whiteflies.
I'm also growing vegetables to help me diversify my product offerings. The big problem with growing crops here is that the soil is like clay. My soil test showed the soil needs more organic matter and has other deficiencies. Rototilling would just compact the soil even more. It's just too expensive for me to buy soil conditioners every season. I wonder if there is a better option.
Our use of cover crops on our farm are primarily for helping to maintain soil organic matter, which is difficult in a continuous cropping vegetable system. And it also gives us a hedge on having to purchase a lot of fertility from compost that we have to buy.
These are oats and field peas that were planted about mid-April. They fit into our cropping scheme because we grow a lot of late fall harvested crops, and they're harvested in late October or November when it's too late to establish a rye and vetch cover crop. So they're left open over the winter. As early in the spring as possible, we get the oats and field peas on. The oats are broadcast just by hand. We put the oats in a bucket. We use other small grains that we might have around. We walk down the tire tracks and throw handfuls and directly apply them to the bed. Then the peas are drilled with our 4-row Planet Junior seeder. The reason we do that is because the peas need to be drilled more deeply than the oats, and the pea seed needs to be economized because it's quite expensive, so we like to plant just the 4 rows rather than broadcast the peas over the bed.
Cutting it about 6 to 8 inches tall, taking it down from, say, a foot to 2 feet. And that seems to give you really good regrowth and encourages that vetch. Right before incorporation, I try to mow as tight as I can get it cut. Again, to chop the material as fine as possible, and so the stubble isn't as much of a problem for breaking down. So this is what it's all about, growing cover crops. When you get soils that look like this, that are just impregnated with roots from the cover crops, just like spider webs through this thing, making habitat for earthworms, and then you have soil nodules from vetch there that is just going to feed a crop that's coming later.
You have to look at the cover crops and say, do they use or produce the nutrients that that specific plant needs? Do they conserve or use soil moisture? And do they encourage or discourage insect pests? What is the length of the growth cycle of the cover crop compared to the actual vegetable crop? And then when do you plant it to have that impact on weed prevention? So as you can see on the picture on the right, in the center there, that actually is a green pepper, okay? So we planted the buckwheat, it grew very quickly. We had kind of a coolish spring, so that green pepper plant did not grow quickly, and we ended up with the buckwheat overshadowing the green pepper. So this is just, to me, a good illustration of picking the proper timing and maybe the proper cover crop. We're going to use the plastic mulch for the tomatoes. We did the interseeding of the crimson clover, and it just did not work out well for us. We had a lot of weed pressure, so that may be some reason for that, but overall it just didn't, for us, do the trick. For the summer squash, we had a great success using those icicle radishes. We did use white clover in the aisles, and that was very successful in fixing nitrogen. So you can see the picture to the right, the white dots are actually nitrogen that was fixed in the soil as a result of that white clover. For broccoli and onion, we will use the plastic mulch for the onions, and the crimson clover worked well for the broccoli. Here's a chart that kind of illustrates some of our data. On the left-hand side, we're looking at weed count. The yellow is the hoeing, the green is the cover crop, and the kind of the orange or red is the plastic mulch. And you can see that as far as weed count, the plastic mulch was most effective, but the cover crop was pretty close to it.